This TinkerCad tutorial will show you how to use a ultrasonic distance sensor to gauge the distance of an object and then use that information to output to two different responses, one with LEDs and one with a piezo buzzer. So the first thing I have set up here is my Arduino with my 5 volt coming to my positive terminal here and a ground coming to the negative. So let's grab a ultrasonic distance sensor. If you're in the basic components and you scroll down, you will find a sensor, but it is only a 3-pin sensor. I found those not as easy to work with. So if I click on basic and go to all, and then I scroll down, I'm going to look for this 4-pin sensor. And I'm going to click and drag that into my workspace here, and we'll just put it right here. Now, if you hover over these pins, they'll show you what the different functions are. So the first one is our VCC, that's our power in. We've got a trigger pin, which is going to send out the ultrasonic audio signal, kind of like sonar. It sends it out. It's going to bounce off an object and return to the sensor via the echo pin, and then, of course, our ground pin. So the first thing we want to do is drop our power in. So we'll use a red to go to our positive, and then our ground to our negative. We'll make that black for clarity. Next, we're going to wire these 2 pins to our Arduino board. Doesn't really matter. I'm just going to use 13 and 14. So 13 is going to be our trigger pin. And we'll make that orange. And then our echo pin will come to 12. And we'll make that, I don't know, purple. Now, since this build is going to use several of these pins as different inputs and outputs, I'm going to show you an optional trick to make your life a little bit easier using the define function. So it's hashtag define, and now we can, instead of using numbers later in our code, we can actually use some language. So the first thing we're going to do is trig pin. And our trigger pin is our orange, which is going to 13. So we can use that. And then we'll also do our echo pin. And that's in number 12. So now later in the code, instead of using numbers, I can use these terms. And that way I don't have to remember which one I plugged into which. So let me close out the code. Next, we're going to throw in some LEDs. And I'm going to do my standard kind of stoplight setup with a red, yellow, and green LED. So one way to think about this is, maybe you're using this in your garage to, when you're backing in your car, to know how far is far enough that you'll be able to close your garage and not hit the back wall. So we'll have 3 different distances based on our sensor, and if we're far away, it'll be green. If we're close, it'll be yellow, and then when we're about to hit something, we'll have red. So I've just got my LEDs and I've got my resistors going to the negative. So now let's wire these into the positive into our Arduino, and let's just do 1, 2, 3. Make that yellow to make it easy to remember where we're plugged in. And I'm going to go ahead and define these as well. Okay, so bring back my code and type in some more definitions. Okay, so I've got my green, yellow, and red LEDs as my 1, 2, and 3. The last thing we have to define are a couple variables. We need to define a variable of time, which is the length of time it takes for the audio signal to go out, bounce off the object, and return. And then we're going to convert that time into a distance so that we can use it to measure different things. So we just use the term long for that, and we've got our duration, and we've also got long distance. Add our semicolon after each one of those, and that's all we have to do for our definitions. Next, let's go on to our setup. So void setup, open and close parentheses, and open up a fancy bracket. And this is where we just define all of these pins as either inputs or outputs. We're going to have a bunch of outputs and then 1 input. So pin mode, and here's where we get to use some of the language that we set up. So our trig pin is going to be an output. all caps, because that's sending out the signal. Our echo pin is our only input, because that's hearing the signal coming back in. Then we have our 3 LEDs. So green is going to be an output, yellow is going to be an output, and of course red. Okay, that's all we have to set up for our setup. So let's move on to our loop. So void loop, parentheses, and fancy bracket. So now is where we're going to send out an audio signal from the sensor. To do that, we want to make sure we send out that it's in a low-powered state. So the first thing we're going to do is digital write our trig pin to a low power state, just to make sure it's off in case anything gets messed up later on in our loop. Okay, and then we're going to add in a brief delay, really brief, and it's so brief in fact that we're going to add the word microseconds to our delay function, and we're just going to delay for 2 microseconds. Okay, next we're going to copy and paste this because we're going to write it to a high-powered state for duration of time. So our trig pin is going to be written to high, so it's sending out an audio signal. Make that a little bit longer. We're going to make that 5 microseconds, so beep. And then we need to turn off that signal again. So I'm just going to copy and paste that. We don't have to add a delay after this because it'll be off for the remainder of our loop. Okay, so we've sent out a signal, and 5 microsecond signal. Next we have to listen for that, and we're going to use the pulse in command, and we're going to store whatever that is. That's going to return some microseconds to us, and we're going to store that as our duration. So duration is going to be equal to pulse in, lowercase except for the I, and the pulse in, we're listening to our echo pin, and once that is in a high-powered state, so once it's receiving that ping signal back, it's going to go to a high-power state, and it's going to store that duration as our duration variable. Okay, so now we've got the time that it took to send out the signal, bounce off an object, and come back. We'd like to convert that to distance to make it a little bit more usable. So the distance is going to be the duration, and then some math. The speed of sound in meters per second is 343, and actually it would be a little bit more usable for us to do that in centimeters. And again, the sensor is using microseconds, so the math just moves our decimal place over quite a bit, and that gives us this equation of 1 over 29.1. The problem with that is that the sensor is sending out a signal, it's bouncing off an object, and it's coming back. So this is actually twice as long amount of time that the object is from our sensor. So we really only want half that duration. So to get half of that, the only thing we need to do is multiply our denominator by 2. So if we divide our duration by 58.2, that would give us how many centimeters away the object is. If you're like me and you prefer to use freedom units, here's the math for inches per second, inches per microsecond. And again, that equation is 1 over 74. We double the denominator to be 1 over 148. So all we have to do is our duration divided by 148, and that's going to give us how many inches away from our sensor our object is. Now that we have our distance, we can use that to output to our LEDs using some if statements. So if our distance is greater than, and this could be however far away you want it to be within the limits of the sensor. If we're using kind of a garage pulling the car in, maybe we would say 8 inches is going to be far enough away. If it's greater than 8, we're going to be on our green. So if the distance is greater than 8, then we open up a bracket, and we're going to digital write to our green. That's going to be high, so our green light will be on. Our yellow is going to be off, our low-powered state, and same thing with red. You can see as using those red, yellow, and green instead of numbers has made my life a little bit easier here. So we've got green high, yellow low, red low, close that bracket. And now I'm just going to copy and paste this for 2 more instances for what happens when we have our yellow LED on and what happens when we have our red LED on. For yellow, we need to make this distance less than, and let's actually make it go ahead and be less than or equal to 8 inches, and double ampersand distance to be greater than or equal to, and again, it could be whatever we want it to be, let's say 4 inches. So in that case, our green is going to be low, our yellow is going to be high, and our red is going to be low. Lastly, if our distance is less than 4 inches, then green is going to be low, yellow is going to be low, and red is going to be high. Whoops. H-I-G-H. Just so that we're not overtaxing the Arduino, we're going to add a brief delay here at the end of 50 milliseconds before it goes back to the top of the loop and pings out again. And that should be our complete loop. And we're going to close off our bracket to close our loop. Okay, let's see if our code is working. Distance is greater than 8. Let's check this here. Problem is I forgot a semicolon here after our equation there. Let's try again. That looks to be working. So now let's go over to our sensor here. And these numbers here are automatically generated by the software. This has actually nothing to do with our code. It's just showing us actuality, how far our object is from our sensor. Since we're greater than 8 inches here, you can see that the green LED is on. As I move closer to 8 inches, actually 8.8 since we didn't use any decimals, our yellow has come on, our green is turned off, and if we get under 4 inches, you can see our red has come on. So our input and our output are working. Maybe as you're backing into your garage, though, you can't see these LEDs and you'd rather have an audio signal. So let me show you how to rig up a piezo buzzer. I'm going to scroll down over here in my components and bring over a piezo buzzer here. And if I hover over, I can see my negative is going there. And I'm going to bring my positive down actually to terminal 0. And I don't know, turquoise sounds lovely. Okay, so let's jump back into our code and let's actually define this. So we're going to define buzzer as 0. Okay, we also have to tell it that that pin is going to be an output. So buzzer is going to be an output. Okay, and then we can add that buzzer to our code here. Okay, so when we want the buzzer to go off is when it's very close, our red. Okay, and the command for that is pretty simple. It's just tone. So our tone is going to be our buzzer. And then whatever hertz we want it to buzz at, we can tell it. So just for now, I'm just going to say 1,000 hertz, which is kind of a medium high-pitched sound. And then we close that bracket. So when it gets to be really close, it's going to set the buzzer off at 1,000 hertz. We also have to tell it to not be buzzing at these other times. Oops. So again, really simple language here is no tone. And we're actually going to capitalize the T there. No tone for the buzzer. And we actually can get rid of this 1,000 because we're not telling it to do any hertz. And let's pop that into our green as well. So there's no tone for green and no tone for yellow, and a 1,000 hertz audio sound for when it's in the red. So we start our simulation, click on here, and you should be able to see, it's going to be loud in my ears, but lights up when it's close there and sends out an audio signal. So there you have it. There's your code and some pretty easy functions with that sensor. Next, I'll show you how this works in real life. So here is that HC SR04 4-pin ultrasonic distance sensor. I just want to point out that when you're wiring this into your breadboard or into the Arduino, Make sure you pay attention to the markings on the back with your 4 pins. Sometimes the setup in TinkerCad lists the pins in a different order. So just make sure when you're wiring it that you pay attention to whatever markings are actually on the one you have. So here's our ultrasonic distance sensor. I've got it wired pretty much identically to how I have it wired up in the software in TinkerCAD like I just showed. I've got all my wires here. I've got my 3 LEDs, my green, my yellow, and my red. And then this is our piezo buzzer for our sound. I've got the Arduino all ready to go, so I'm going to plug that in and load in our code. Okay, so I've got my distance sensor over here. I've set up a little tape measure, and remember that we had set it for any distance greater than 8 inches. It's going to be green, which we can see that lit up there. As we move within the 8 to 4 inches, that should be our yellow section, and then under 4 inches should be our red section, and our buzzer should go off in that circumstance. So we're just going to use this lemon. If we get to 8, there. So it's pretty accurate. You can see right as I'm crossing over into 4, it turns red. Let's move back over here, right around 8 inches. It's kind of hard to see with the camera angle. If I move this over a little bit, you can see that I've just broken the plane on the 8 inches is when the yellow goes over there.